Thank you, Matt. I'm delighted and honored to be joined today by our panel of experts who are here to share their perspectives and discuss strategies and methods for teaching robotics with AR and IoT. As always, please enter questions into the chat and we'll pass them to our four panelists, who are Horst Ursulitz. He's the head of the Competence Center of Virtual Technologies and Systems Engineering at the University of Applied Sciences, Technikum Wien in Vienna, Austria. Chris Rogers, professor of mechanical engineering and advisor to the Center for Education and Outreach at Tufts University in Medford, Mass. Tashkin Padir, associate professor of electrical and computer engineering and director of the Institute for Experiential Robotics at Northeastern University in Boston, Mass. And Anthony Neiswander, president and CEO of APT Manufacturing Solutions in Hicksville, Ohio. Thank you all for making time to be here today. PTC sees augmented reality and the Internet of Things as key enabling technologies for making people, processes, and products smart and connected, in short, more interactive. And AR, of course, enables easy visualization of 3D geometries and also allows us to experience things and perspectives that may otherwise be unavailable to us, like, for example, viewing the solar system from above. And we understand that connected smart objects and the Internet of Things can also be used in the classroom to empower students to learn coding, electronics, engineering in nice, in hands-on and interactive ways. And we see a potential opportunity to leverage these tools for teaching robotics, especially in the context of smart manufacturing. And as we think about that, we see that robotics and automated systems are getting more complex. It can be hard to know what they're thinking. So for my first question, I'd like to start with Chris and ask if he could talk a little bit about how he sees AR lowering the barriers to understanding what's happening in these systems.
What a surprising question. I never would have guessed you would have asked that one. So yeah, we've been working now for quite some time. Actually, Mark Celli, who I believe is on this call, was responsible for dragging me down this rabbit hole. But the idea of what happens if students could actually look inside their robot and see what their robot is thinking has a lot of potential and is quite powerful, I think, as we move forward. So I do a lot of this with a colleague of mine at Tufts, Jivko. But I figured instead of slides, I would actually show you sort of what I'm thinking. So what I'm thinking is our process is going to change. Right now, everyone learns to code their robot, but I think as AI gets better, we're going to start to learn to train our robot. So let's take an example robot. This is a very expensive robot made out of Lego. We can train our robot that we want the motor to be in this position with this amount of lighting. So I'll grab some lighting. And then I'll say, well, no, eventually I'm going to want it to be in this position if I cover over my light sensor and it's this amount of lighting. Now, suddenly I have this thing that moves my motor to two different positions, right? Brilliant, isn't it? So I haven't had to use a computer. I didn't learn any coding, but I have no idea of how this thing is actually making this decision. You can see if I jiggle it around, sometimes it moves even if my hand's not on a light sensor. So what we're playing with now, and if you go to the poster session, Millen, the graduate student who's working on this, will show it to you, is what if you take out your phone? Can you see into the thinking of that robot? And how will that actually help you decide if you should retrain, if it was a bad training, or change the training, or change the underlying model? So this is sort of how I see AR really lowering that barrier to entry very quickly, because I can actually sort of see what the robot is thinking and why it's doing what it's doing.
Great, yeah, and I know you've done some work to show and visualize with AR what the various sensors can see, right, as one might interact with them. Can you talk a little bit about or give guidance to educators who might want to incorporate AR into their classroom, how they might do it? And what for you?
So AR is very young still, and what we found, we've brought it into classrooms anywhere from elementary school all the way through college. There's a number of things that happen, especially in elementary school. If you're looking at your phone and someone goes, well, what does it say? Now you hand them the phone and suddenly it's no longer looking at the robot and they can't figure out what's going on, or they're just shaking and so things are moving around and it's hard to follow. Obviously, as they become more advanced and more, have more experience with it, they get better at it. I think when we really start talking glasses is when it will really start to change. And
Mm.
someone says, "Hey," and you turn around and suddenly you've lost all that information. So I think there are a number of barriers, but it's pretty exciting to see how quickly the next generation is taking it up and how they want to then start controlling it themselves.
Great, great, yeah. So on that note, and speaking of the next generation, maybe I have a question for Tony. I'm really curious to know from his perspective, in APT's perspective, where industry is headed in terms of adopting AR. And as educators like Chris and others are working to educate and create the next generation workforce with skills and comfort with AR, what are the industry needs around that in order to make that happen? And what guidance would you give to universities who are working on educating these students?
Interesting. So, Chris, I appreciate your answer of one of the comments you made is AR is very young, and it is. So I'm on the receiving end. You guys are on the building end, and we have about 100 employees here at APT. We're a very large FANUC robot integrator. Industry, I find industry moving towards AR to reduce downtime, troubleshoot, look ahead by programming different scenarios prior to the implementation. Currently, right now it's a hybrid between the physical and virtual. So when I look at that in the FANUC robot world, because that's the world that we live in, we're now using AR to see, for example, dual check safety. We call it DCS, dual check safety. Dual check safety is when you program a robot with a bubble around it that can't be seen. So that bubble says, if anything enters into this bubble, I'm going to stop. So normally when you're talking about that world, you talk about the distance between the end of arm tool, maybe in the cage. So can it pin a body up against the cage, or do we have 18 inches? We also talk about that when two robots are playing in the same space. So this is my space, this is your space, but you can't see it. But today, FANUC now uses that through glasses that you can bring the program into reality on the floor by testing and troubleshooting, either prior to putting it in the real world or in the real world. So it's kind of neat now. You can see that bubble, and you take those glasses off and you no longer see the bubble, but really you're now seeing, like Chris said, through the robot. What's the robot seeing, and where's that bubble at? What are the industry needs in order to make it happen and happen sooner? I'm going to push this one back to education, since there's a lot of education here. So really, we need a strong, proven foundation to move into this world. I believe it'll start from a new project or on a maintenance side, like we're doing. The biggest thing will be ease of use. Looking at the iPhone 10 years ago and looking at the iPhone of my father's 87 years old and has an iPhone and gets around with it pretty good. But 10 years ago, there was no way he could. And I look at that a lot in my company. I'm 56 years old. Do I want to go into this world? No, not really. But do I need it to come to me? I do. And the way we're going to adapt to that is by hiring those employees, those students that come out of universities that says, oh, this is no big deal, I got this. And then we can believe in them. So really what you're doing there is, to me, is pretty neat. Augmented reality really needs to become like a collaborative robot. So if you look at collaborative robots 5 years ago, 6 years ago, where were we? But today we're setting up collaborative robots right beside us, and we trust them, and we know them, and we believe in them. So I think you would ask, what guidance would I give to university and education? I'm going to separate some things out, because in the world we live in, and APT builds all of the FANUC educational equipment beyond a cert cart. So all integrated, all advanced manufacturing, everything that's going into schools that's a FANUC robot, other than the initial cert cart, we build as an extension of FANUC. I never understood all of this prior to getting into the educational market in about 2015, but universities, sometimes I look at universities different, because they're a great tool for advancing the technology and improving AR in general. A university tends to be more analytic and a front runner on new products versus a community college. So if I can separate education a little bit, without hurting anybody's feelings, because there's a lot of education there, but education, really a community college. If I can talk to community colleges, you need to jump in, get involved as a student graduates, as they're employed, that they can bring augmented reality into the workplace. Companies will embrace it. Students will bring it in. But the school needs to be grounded in industry standards. So let's not get so far out of whack that you're bringing it into industry, but it doesn't allow into or line up into our industry standards. Because if that happens, then we can't use it. So if I can separate a little bit of the universities versus a community college, I would say universities, the sky's the limit. What can you do with it? Let's bring us, or let's take us into 10 years from now. Community college, let's bring it into really the hands-on of what's been developed, and can it come into the industrial standards so that we can follow the industry and the safety protocol that we need today. So did that help, Peter?
Yeah, that's great. Thank you, Tony. I appreciate the perspective. And it's a couple of good questions. I liked what you talked about. I think I'm interested in where you talked about the ease of use and also about the industry standards. And I wonder if Horst could talk about that a little bit. Horst, I know you've built some tools in with your research team that leverage AR for teaching robotics and understanding 6-axis industrial robots. And I wonder if you can talk a little bit to those to what you've done and how you thought about perhaps using AR to make learning robotics easier, and how you also, to Tony's point, think about industry standards.
I'd love to talk about this. Thank you very much, Peter. And to all others, hello from Vienna. Good afternoon. We discovered AR as a very suitable tool a couple of years ago to decrease the cognitive effort, as Jim Heppelman states it, because teaching robotics is kind of complex, because it's a six-dimensional problem, 6 degrees of freedom for an industrial robot in a serial kinematic chain, where you orchestrate those 6 axes in order to bring the robot into movement, most likely a line or a circle, or whatever the pick and place application looks like, or your welding application or whatever. And there's a lot of mathematics going on in the background, in forward and inverse kinematics. And we are teaching robotics in fundamental courses. So we try to explain using slides and videos the fundamentals for coordinate transformation, matrix multiplication, and stuff like that. And it's kind of a challenge for a young student to identify those problems and transport it back to 3 dimensions and the physical world we live in. So what we use AR for is, just let me share my screen for a sec. Whoops, it's the wrong one. That's not Vienna, actually. So we use AR to superimpose the current angle information on the industrial robot, to be able to explain a little bit in detail what's going on in a robot control. How does the inverse kinematics work? What mathematical application, mathematical calculation need to be done in order to orchestrate these 6 axes to move along a line.
First, sorry to interrupt it. We can't see a video. If you're sharing a video, we're just seeing a folder.
Why can't you see a video?
We saw a folder window with a video icon, I think.
Oh, I should start the presentation as well. Can you see it now?
Yes, it says virtual engineering education. Looks great.
Yeah, awesome. So on the left side, you can see superimposing axis information, which is first axis, second axis. How is the coordinates system localized within the axis? What's the base coordinate system? Stuff like that. And the second video shows what I explained, quite enthusiastic, the 6 axis values, the angle information from inside the robot. So as Chris stated out, AR combined with IoT gives us like X-ray vision and allows us a better understanding of what's going on inside a robot, so that it moves along a line or a designated path within the robot application. And this helps us quite a lot to start with the complexity of forward and inverse kinematics. And then we can hand out an AR application to our students where they can use on their mobile phones, wherever they are, drop down a thing mark, as Yuri stated it, and interact and use the application to gather information about an industrial robot wherever they are, especially with distance learning, this kind of powerful tool, so they can get inside information on the data sheet. They are able to control each axis, to learn and understand first axis, second axis, how the serial chain works together, data sheets and stuff like that. We even went further and did a combination of this application with IoT, so that I am able to control the 6 axes and my students see the AR experience in their mobile phone moving, and I can accordingly explain to that. If we have time at the end, we could try with the audience. If there is time left, let's see. If not, just hit me and we exchange the thing marks and slides for a test run. So we figured out after a short survey that first of all, we get a better approach to the students. Not that it's necessary to raise their interest when dealing with robotics, because for most of the young students, robotics itself is kind of, they're very curious on that topic. But in order to find out how everything works, how the details work out, what's the math behind, we can use AR to increase learning over time.
Great, thanks, Horst. Yeah, great to see that you can leverage AR to lower that barrier. And good to see the use of IoT as well. And I think we all understand the value of AR is significantly higher when we can integrate IoT data and overlay it onto our systems. So, I wonder, when we start to get out into the industrial space outside of the classroom and to mobile and factory robotics and more complex systems with humans in the loop, as we've been discussing, I'd like to ask Tashkin, what his perspective on this is. How does he see AR being leveraged in that space, and what's the role of IoT as well?
Sounds good. Thanks, Peter. Let me first frame some of the challenges, perhaps, that that still exist, right? Anytime we interact with robots, we always hear that, oh, robot did this, but I don't know why it did that, right? So, I don't know why the robot took this action, especially if there's a failure mode, right? So we always hear this from our students, from the practitioners and whatnot. So I think the immediate impact of the AR technologies will be that transparency, right? Because as Horst nicely demonstrated, we can now start adding some more intuitive meanings to robot actions and communicate that to the humans that are in the same environment or operating the robot in a seamless way, in a way that we understand when we look at the system. Now, I also agree with the earlier statement that AR or the applications, the use of AR is still in its infancy when it comes to the development efforts, and we have tremendous opportunities once we get to the full potential of the AR with the IoT, with the smart, the whole connectedness. We can do things like knowledge transfer, right? So you have this technician, who knows how to operate this complex, maybe one-off machine, who worked on this more than 30 years, and he or she understands the little hiccups, for example, right? And then when this person retires and moves on in his life, the knowledge transfer becomes an issue. I mean, we all run labs, as a research lab director, for example, right? So that's the same issue, right? So one of my students graduates, and then how do we capture the data? All the tools, you can get all the software, you can get all the, documentation, but there's always something, right? So there's always that intuition that is built into the person. So knowledge transfer can be interesting, right? So now imagine a smart work cell where this person is operating, and we talk to our environments, right? So we communicate in spoken language, we communicate in nudges, in actions, and imagine this IoT having the capability of capturing actions, capturing orders, sequences of actions, and affirming some of those actions through the AR interface, and capturing that knowledge. I think this whole concept of knowledge transfer is pretty exciting, and we are just scratching the surface of it, right? So all the visuals that we are adding is just one step towards that. Task guidance, right? So all of a sudden, you have a new technician, tending a complex machine. Now you can take that knowledge transfer and start providing cues. Oh, if this doesn't happen, I don't have to scroll through pages after pages of manuals and troubleshoot. Troubleshooting becomes more straightforward and easy. I worked on assistive robotics for many years. I still, have a number of projects. The concept of personalization, when it comes to human-robot interaction, it is a hot topic. It's a difficult topic, but we are not there yet. What do I mean by this, right? So, my interactions with my tools, imagine your interactions with your smartphones, with your gadgets, can differ from day to day, can differ from morning to the afternoon, or, it will differ from person to person. So, again, the visualizations and this knowledge capture concept that comes with the AR and all the surrounding smart gadgets will be instrumental, in my opinion, to get to the full personalization, right? So it will be easier. So again, I think transparency, interfaces for personalization, and this whole task guidance, knowledge transfer aspects are definitely keeping us going on the research and development side of the house to realize these in real environments.
Great. Yeah. Thanks, Tashkin. It's so exciting to think about all of these applications. Does anyone on our panel want to add to that or have any thoughts to follow up?
Totally agree.
All right, great. I want to go back maybe to a point that Tony brought up about standards and thinking about how we make sure that the students that we educate in these technologies are educated in a way that's compatible with industry standards, so that the skills they end up in industry are immediately useful. And that probably in itself is challenging enough. And I think also I'm curious to know how you as educators think about balancing the needs to satisfy that requirement with also wanting to make sure that we teach students about problem solving in the sort of the 21st century skills of critical thinking and collaboration and et cetera. And maybe we'll go back to Chris. Do you want to start and talk about that a little bit?
You're not going to like my answer, though.
That's all right.
I see the university as a place where we should really be thinking outside the box, right? So thinking where could things go, what things could happen, and then really I see the now pulling it down to standards is something that would be much more in the industrial side of, well, I can leverage that, but this area is still too new or too different. I think the interesting one that comes to mind as you were talking was, I don't know how many people are familiar with the issues around machine learning and radiology. So that if you look at the existing standards of how things get approved, you can't actually actively change the learning that the machine is doing. And so you get stuck in whatever training that radiology system was trained in. And so what works great in Massachusetts doesn't work at all in San Diego. But you can't change it because you have to go through a whole nother approval. So FDA, there we go. So standards often can hinder these things from happening, which is for good reasons, but maybe the university is a place where we think without the binding of the standards.
Great. Yeah. So if then the workforce training is happening at a different institution or a different type of institution, perhaps, do we imagine a way in which we can share the knowledge between the sort of cutting edge learning from the research universities to those other entities, to those community colleges, or how can they does anyone have thoughts on how that collaboration might happen?
I can quickly perhaps add to what Chris mentioned. Now, there's no reasonable way to include everything in an educational setting at this point, right? But then what is happening, what we see happening is that our students are going out during the summer months for their internships, for co-ops. And these are not just jobs. These are really jobs that are relevant to their education. So what is happening, this whole learning and being trained as an engineer or an engineering technologist, it is, we like it or not, and then we recognize it or not, it's becoming a two-pillar activity, right? So they come and take their classes, do their projects in an academic setting at the university and have fun, and then go out and have these experiences in an industrial setting where standards, ethical considerations, and other aspects can be elevated, and that becomes then when you focus on the individual engineer, then the engineer becomes full. And I think we need to start building those bridges more tightly, right? So we need to start looking at, okay, so our students get these types of experiences and learning in an academic setting, but then all these are complemented through their industry experiences. I mean, coming from Northeastern, we have a very active co-op program, as you probably know. And sometimes I cannot even keep up with the students' knowledge that they gain during those co-op programs.
I imagine there's very little substitute for that actual real experience of being in a factory working next to a live robot. And so yeah, it makes a lot of sense that would be a core part of that learning. So I'm curious, maybe we could look a little farther ahead. As many of you know, PTC has a relatively new technology for spatial computing, which incorporates AR with the ability to, say, change or control physical equipment, PLCs or robots through AR. And so I wonder what you might think of where this is the cutting edge of AR technology. Do you see an opportunity or any barriers to integrating this into classrooms or factories? Has anyone played with spatial technology and had an experience that they might use to or might be able to leverage to give us your thoughts? Horst?
Maybe I jump in this time. Yes, we experience, or we investigated and experienced the spatial toolbox a little bit together with Chris in a project as well, which was pretty fun to do, where we connected the spatial toolbox to Onshape and put some robots into a drawing, in a combined drawing in Onshape. Aside of that, the presentations from Valentin Hoen and Anna Faste and her team in the Reality Lab are pretty impressive. And especially bringing the whole smart manufacturing thinking or Industry 4.0, whatever, to a next level. I think Yuri showed very impressive presentation and examples of where the digitalization road is leading and alongside which steps are necessary to take there. And the spatial toolbox are helping to put processes and technology itself into perspective to be able to understand, to be easier to understand for students, in my opinion. So if you can see the connections between a mobile robot and the industrial robot, where the mobile robot tells the industrial robot to start his operation along his way, and you can visualize this with the spatial toolbox, it's making magic visible somehow. I'm picturing it a little bit. Of course, there is a lot of software development in the background, and it's not out of the box yet. And that's also like the hard line between university and industry. We're quite close to industry as well here. And I understand and did a lot of risk assessments and all the standards which are necessary for robotics in industry. You have to put a fence around it. You have to have your scanners and security sensors and emergency stops and stuff like that. We teach that as well. But with Chris, at a certain level, we need to push our students to go beyond these standards and find new ways of interacting, programming, and setting up a robot cell. And then try to answer the question about security. And the Spatial Toolbox is a tool for a unique programming possibility for robots. We're transferring that now to a HoloLens, so you have hands-free for interacting with the machines. We transport the idea of that. So this opens up totally new interaction between worker or programmer and the robot. So I think it's a very powerful tool. It's going to be interesting to find out whether it's going to be accepted in industry within all these standards and regulations. That's always a challenge for new technologies. We're dealing with mobile robots as well, and we're in a research program dealing with safety standards and mobile robots. So if the mobile robot dynamically changes path because the next step is shorter to do at station A than at station B, how does this robot need to be equipped in order to be safe for all the people in the factory floor? Tricky questions. We're pushing them.
Yeah, good points, Horst. And I think you talk about a little bit, when you say you're picturing it, I picture these, we've talked a little bit about these interfaces and making the interfaces more transparent, and great to be able to sort of see what these machines are thinking. I'm curious, as Tony mentioned, collaborative robots and other robots are very common in industry. And I wonder if all of you could speak to any ideas you have on how AR will allow people to work more closely and safely interacting with these robots going forward, as I expect that's going to be more and more common, right? That we're going to see robots and humans working even more in pairs together. Does any, Tashkin, you're nodding. Do you have thoughts on this?
Yes. And again, I'll be very brief given the time. If we go back to this whole future that I laid out, where there's intelligence embodied into our environments, right? So there's monitoring, activity monitoring, and whatnot. I think an IoT system that can detect, hey, this is a safety hazard for this worker to be doing this, then AR can be integrated to nudge the worker, right? So to inform the workers' decisions, actions, activities for a better and safer environment. Again, we are not there yet. This is, there are tidbits of this being worked out in research settings, and it's a good thing, right? So this is how it all starts. But I think, from training new workers to sometimes really, especially if the applications are high consequence, right? So you're perhaps, working collaboratively with the robot to handle, dangerous materials, right? I think there's great opportunities for integration of AR and all around ambient sensing to make an impact in that safety aspect.
Great, yeah, Tony.
So let me say a couple things. I agree 100% when we're talking about training. That's so true, because what we can do with augmented reality is build a comfort level for the operator to now feel comfortable about where the robot is, things you can't see, with your eyes, and you can feel comfortable working with them. Some of the things that when I talk about industry standards that may be developed in an educational market from a university, which I'm all for it, 1,000% for it. Okay, I'm excited about it. But when it does come to industry, then you had mentioned a risk assessment. We do a risk assessment. We're RIA certified. We do a risk assessment on every robot cell we build. But it's interesting because there's collaborative robots, and you have collaborative robots in your classroom. They're 100% collaborative. You can work with them every day until they're on my industrial side. Then is the gripper collaborative? Are they picking up a razor blade, for example? Let's just use that as an example. If the collaborative robot's picking up a razor blade, it's no longer collaborative. But from the robot company, they sold you a collaborative robot. So the student needs to understand that this is a collaborative robot. It touches you, it stops, everything's good until I pick up something that doesn't make it collaborative. And then that's where we're saying, okay, can it be used in industry? Is it as exciting as what the robot companies say it can be used anywhere? That's kind of a mute point, because as a robot integrator, I'm still responsible for industry standards and safety. So I'm glad you brought up the risk assessment as well, and also on a training tool. I think we need to make the operator comfortable working with robots, and augmented reality can help that. But we also still need to understand that if you touch a wire, it can still bite you, right? We still have to respect it. So.
Yeah, that makes a lot of sense. Of course, you know, I've experienced that working with a collaborative robot is as great as they are, they still, it takes some force to stop it, and they can be sharp. So I'm curious to know, when you hire students, new students into this space for in you know, maybe for the more smart factory applications that you're involved in, where there's collaborative robots or industrial robots of any sort, what are the skill sets you look for? Or what are the skill sets that you have trouble finding that don't exist or are harder to find these days that you hope for the future?
So that's interesting. When we look at a student and bring them in for the first time, we're really looking for that student that doesn't have a deer in the headlights look when they walk on our floor. So sometimes they come out of they get a degree at a school that really doesn't offer automation, mechatronics, industry 4.0, augmented reality. And they're walking in here thinking, for the last 3 years, 2 years, 4 years, I've been working on this and I know it. And they walk in a deer in the headlights and they're like, I've never been around what you're building. So somehow we have to make sure, and one of the things that we build for FANUC is industrial robots for the educational market, because we have to make sure that we're still bringing industry into education. Not that what the university taught them was correct, but we want that comfort level from a student to be able to walk in and say, I'm comfortable working in your plant because of my surroundings in my classroom. There's so many similarities. So we need to make sure that we keep in touch with industry as we build the classrooms. So we're looking for a student, to answer your question, we're looking for a student that really understands the industry side as well as the education side, so they're comfortable when they're walking in. That's what we really look for.
Great, that makes sense. That's wonderful. And I'm afraid we just have a few seconds left. I wonder if there are any closing thoughts from any of the panelists they'd like to share. Chris, I saw you.
Definitely the future is very promising, and we should continue the conversations and share success stories.
Wonderful. Yeah, agreed. It's a very exciting time, and it's a very exciting time to be working in this space.
Once again, I need to agree with Chris. We are experiencing the same issues right now. So we put technology, AR, and the Vuforia Studio into the hands of the students to solve a problem and to develop an experience to solve a problem, actually industry-related problem. And they start getting crazy like we did with CorelDRAW 20 years ago, and printers and print out every weird stuff. So they are now fooling around with widgets and colors, and UX is going to be a very important part for augmented reality. for me, it's a huge goal in education is to learn or to teach our students problem-oriented, of course, but understanding the tools to solve problems or think about solutions which are not current problems, but problems in the next step. Understanding the potential of having a sensor information superimposed to a machine. What problem can this solve? What can be a benefit of it? What business case or whatever can come out of it? These are the usage of not just the technology understanding, but the correct usage of the technology. Everybody went crazy to have sensor informations in the cloud or data in the cloud. There are, I don't know, 50 billion devices delivering data, and 1 or 2% of this data is beneficially used. So the rest of it is just keeping Amazon rich. So to ask the right question, to come up with understanding of a data model and how to transfer the data and how to use the data is a crucial step from my point of view. That's a challenge for us because in my experience, industry typically don't ask that questions yet. Some of our industry partners ask those questions, but most of them are busy with automation still and not with the next step, how to use the data. And that's one point that keeps me striving and motivated.
Great. Well, thanks, Horst. I can imagine a future panel focused on the data and thinking about how we should manage that. So we'll keep that in mind. And so I want to give a big thanks to our panel. We're so grateful that you would join us today and really appreciate your time and insight on this topic. Please, everyone else, please put questions in the chat if you'd like to continue the conversation. And thanks so much for being here today. Thanks again, and back to you, Matt.